Right. The area of the trapezoid is 1/2 the height times the sum of the bases, or you could think of it as the average of the bases times the height. Now we can talk about why is the area this. And if we draw any trapezoid, would not matter what trapezoid we draw, we can divide it into 2 triangles. Because the bases are parallel, when we draw one of the diagonals of the triangle, triangle 1 and triangle 2, we are going to be forming 2 triangles that have the same height. We talked about how do you find the height of a triangle. If the triangle is acute, the height is inside, and it is perpendicular from the vertex to the base. If I clone this height and move it along here, you notice that this other triangle is going to have that same height. If this other triangle is obtuse, so what I have to do is extend that length out. The trapezoid is divided into 2 triangles. This other height is in fact the height of triangle 2, but it's the same as the height of triangle 1. And it's the height of the trapezoid. Now the reason why that's important is because to find the area of a triangle, you go base times height. So for triangle 1, we're going to work with this base of the trapezoid. For triangle 2, we're going to work with that base of the trapezoid. But the height is the same in both. So the area of the trapezoid is going to equal the area of these 2 triangles. The area of triangle 1 plus the area of triangle 2. Since they're areas of a triangle, it's always 1/2 its base times the height. Triangle 1 has base 1. Triangle 2 has base 2. Both of them have h, the height of the trapezoid. Now, using the distributive property, you can factor out the 1/2. You can also factor out the h. So our result then for the area of the trapezoid is going to be 1/2 the height times, and then what will be left in this first term is base 1, plus what will be left in the second term is base 2. So the area of a trapezoid is 1/2 the height times the sum of the bases. But this brings us to something else that's important about trapezoids, and that is the length of the median. A median of a trapezoid is a segment that joins midpoints of the 2 legs. So if you have a trapezoid, doesn't matter how you draw this trapezoid, and you find the midpoint of each leg, we have a theorem that tells us something about this segment that joins those midpoints. It is parallel, and what about its length? It's the half the sum of the bases. It's the average of the base lengths. So the length of the median, if this is base 2 and this is base 1, the median is 1/2 the sum of those bases. Now, if you take what the length of the median is and what the area of the trapezoid is, you can come up with a new formula. Do you see in the area of the trapezoid the 1/2 and the sum of the bases? So you can also say, since the median is 1/2 the sum of the bases, that the area can be written as the median times the height, because you're taking the 1/2 and the sum of the bases. So the median times the height. If you find the length of the median times the height, you can find the area of the trapezoid. One more thing about trapezoids that we should review.
So that black line goes to the trapezoid center.
That's not the median. The median goes from the midpoint of this leg to the midpoint of that leg. That's the median. Now, the reason why I'm giving you that is because sometimes they give you the length of the median instead of the bases. And so if they do, then you can find the median times the height as the area, because that's 1/2 the sum of the bases. Sorry, Anna.
Go down. Can you go down a little bit?
I'm going to group and shrink so that we can see everything. Pretty much. I'm going to talk about the isosceles trapezoid now, because it's our last new piece of information. And it's not new, it's review. Just like the median was review, isosceles trapezoid, what we know about it is review. So an isosceles trapezoid has congruent legs, has congruent base angles, and when you draw an isosceles trapezoid, and then put altitudes in, you're going to be forming a rectangle and two congruent triangles. When you put altitudes into an isosceles trapezoid, you have a rectangle and two congruent triangles. Just like the assignment I gave yesterday was a little bit difficult because they require that you put all of this information that we've covered in the whole book together about these figures. Today's assignment is the same thing. They take all of this information and we put it together, and you have to use it to find the links you need to find the areas. So look at page 435 with me.